So this week we're gonna learn how to mill circuit boards using several machines. So basically two types of machines. One is that you have what you can see in front of you, Roland Modela MDX-40, which is a bit more powerful machine, and the other one is Roland Monofab SRM20 that is in the other room. So the primary use of this Roland MDX-40 is rubber mold making. So you can make molds like these. So we're going to cover how to make those and how to use silicones and plastics in order to cast it later. But you can use it also for PCB milling, as it's quite precise. So you can install a variety of tools in there. And in order to make the circuit boards, we are using material that's called a FR1, so copper-covered clads, which are basically copper-covered sort of paper, which is fire retardant. And FR4, it's not good to mill, because milling involves creating a lot of small particles, and FR4 is usually made out of glass fiber, and glass fiber particles are not that healthy. So with this machine, you can have an area, so it moves along X and Y and Z axis. So there's a spindle and a tool holder, which can hold different collets and different tools, different collets with different sizes for different tool shafts. So the ones that we are going to use in this exercise are going to be 3.175 millimeter shafts. And so the collet and the spindle, so this structure can move in three directions and three axes, like X, Y, and then Z. And the area that you can cut is 30 by 30 centimeters. And then the Z distance that this machine can travel is about 10 centimeters. Also depending on the tool that you installed there. So for PCB milling, we use these three tools mostly. So they are always here. So if one of them gets broken, then so yeah, you're welcome to replace that or tell us to replace that. So you can find the fresh tools usually here or next to the other machines. So the size of the tools that we use are 0.3 for the smallest details, so for the more detailed boards. Normally we would use 0.4 millimeter tools. And then for cutting and drilling holes into the circuit boards, we use the 0.8 millimeter tools. Also, whenever you finish using the tools, please put them back in this in these boxes so that they do not get lost and also not get broken. As for the machine, so you can turn on the machine. So there's one switch on the other side. Once the power is on, turned on the other side. And the next thing that you do is you press this power button, and it's gonna find its own mechanical origin. And at this point, it is ready to set up. So one thing that you could do is to move the build platform forward by pressing the view button. And I suppose you can use the up and down buttons to move the tool up or down. And this at this moment. Then in order to set up the tool, you need to open the lid. So this one is the collet. So.
Can I take a picture?
Yep. And the thread goes into the machine, into the holder. I'm going to show it here. Focus. So there's a thread, and then there's an opening for the tool itself. Here. And what are we going to do? So we're going to install the 0.4 millimeter tool. So this one here. So with this machine you have to push it in a little bit, but don't push too far. So there's the.
So you just manually push it.
Yeah. So because like when you're gonna twist the thread, then it's gonna press these two sides together and it's gonna hold it tight. So
what's the, can you show me
looks
again
like this.
groove? So what's the depth?
To install the tool, you basically turn it clockwise. Try not to also let it go, so because it can fall and the tool can break. Then you can use these two keys, these ones. So the bigger one goes on top and the smaller one goes on the bottom. Like this. And you can tighten it. So don't tighten it too strong, just the right amount. So as squeezing a lemon. That's kind of the rule of thumb. Yeah, and at this point we can close it down. And let's start out with the Fab Academy assignment page. So when you go to content, to year 2021, in the schedule, then to electronics production, we scroll down. So we see there's an assignment. So individually we need to make an in-circuit programmer, but for this assignment, so for the group assignment, you need to use these two files, so this one and that one, to kind of see how the machine is able to mill this pattern. So the white areas here, these are going to be the copper that is left, and the black area is supposed to be removed. So the same will go for the circuit boards that you're going to create later in the course. So what do we need to do? We need to save both of those somewhere on the desktop. And we can close these safely. And the next is we go to mods.cba.mit.edu, so which is the domain name for the tool. It's a browser-based tool for doing all kinds of things, including PCB milling, creating PCB milling paths, tool paths for the machines. And what we need to do is we need to load a program. And here I right-clicked and selected programs, open server program, and I scroll down to Roland SRM20. So this specific version, so that it doesn't contain a preset for the for the MDX-40 machine, but we can use the SRM20 setup in order to generate the G code for this machine. Then we need to select the PNG file, so which is the line test. So usually start with traces, so with the smallest details. So since we also installed the 0.4 tool, which is good for milling this, which is supposed to be used for milling traces, we load that. You don't have to change any settings over here. And so the next node, so this is kind of a node-based interface. So every node does mean something. It's like a little computer program. So this was made in order to let people better understand what is the process that is happening under the hood in terms of generating toolpaths. So if you're interested, you can follow the lines and you can check each individual module in order to understand better what it does and how the toolpath is actually generated. We're not going to dive into that at the moment. What we need is to adjust a few settings in some of the nodes. And we start with the presets node. So we're going to use the mill traces preset. So with this 164, it's the size of the tool, but this is imperial units, so it's 1/64 of an inch, which roughly equals 0.4 millimeters. So that you can see also here in the next node, which is the mill raster 2D node. So and here you need to specify settings starting from the tool size. So I'm going to specify 0.4 since we're using 0.4 millimeter tool. And here we need to also specify the cut depth. So since we know that the copper layer thickness is 0.1, we're going to specify 0.1. And since we want to remove only the copper layer and we don't want to cut through the circuit board in any way, so we're just going to specify the maximum depth as 0.1 millimeters as well. Offset number, that's a bit trickier to explain, but it depends on the diameter of the tool. So
can I ask about the depth? If you leave it at 0.1, is there a risk that you kind of leave a very, very thin layer of copper there? Or?
There is risk. Yeah, if you see that happening, then you can go back to this process and add a bit.
Okay, so then you just add go 0.1
0.12 or
yeah,
something like that.
I was just like wondering if that's something that happens or.
That happens, like because this process is very manual. There are many things that can go wrong, and so it's basically rapid prototyping. So it's for you to better understand how you make circuit boards in the first place. But then once you get to the first working prototype, then it's of course recommended to actually send your design to the board house, and where they can make like 10 copies, 100 copies, and then you can do the SMD soldering yourself or ask them to do it. But this is a nice way to actually make your, let's say, interactive arts projects look nicer. So instead of a box with a lot of wires, you can have a nice circuit board where all the components are actually nicely fitting in place. And also the longevity of your project actually increases that way. So because like if it works, then you can use, let's say, transparent or like any kind of other epoxy, so you can cast it into something, like shield it off from the environmental impact. And so yeah, 0.1 is a good starting point. So it's a similar thing like as with the laser cutter. You can take these values in the text file as a good starting point, but never assume that they're gonna be perfect at all times. So you always do a small test if possible. And this was what we are doing right now. So offset number means that so the offset number is related to offset step over. So offset step over is the percentage of the diameter of the tool. So if you set it to 0.5, that means the half of the diameter of the tool. So in our case, if it's 0.4, then 50% of 0.4 is 0.2. So that's going to be the distance of one level of offset. So or one. So this is the amount of times the toolpath is going to try to go around each of these white islands. So which means that if there's a 0.4 tool, so it's going to mill around once and then offset by 50% of its diameter. In this case, it's 0.2, and mill around one more time, then again offset one more time until it reaches the number of offsets that is defined here. If we set up it as 0, that means that it's going to try to remove as much as possible, so all the black area basically. So 0.4 4 is a good number. We can also go with 5. It's going to take a little bit longer, but that's okay. So for the direction climb or conventional, I'm not going to cover this, but you should select climb whenever possible. That's going to end up with a cleaner cut. And yeah, these are optional. So for the Roland SRM20 milling machine, speed. So the recommended values for the tools that we are using, which are really brittle, and we want to change them actually. So for the 0.4, you would like to go with the speed of 1.5 millimeters per second. If you're using the 0.3 tool, then you reduce that to 1 millimeter per second.
Are these values somewhere?
Yeah, there are. They are next to the other machine, and I'm going to make actually a sticker here as well with the values. And then for the 0.8 millimeter tool that we use for cutting out the board, we use 2 millimeters per second. So here I'm going to set it up to 1.5. Then the origin, so we want to assume that, like we want to have visual contact with the origin. We're going to set the XY origin in a minute, but we want to assume that the origin here matches the origin that we just set, that we are going to set in a minute. And jog height, it's the height above the circuit board, above the material, which is going to be used for rapid moves. So for example, when it's finishing cutting one path, it's going to lift, the machine is going to lift the tool and move to the beginning of the next path. And this is the height for that process. And for home position, we can set it the same as the origin. So it's going to be the position that the tool is going to try to go to in the beginning and after the cut. And yeah, the Z, it's good to actually have it above, because if you set it also to 0, then It's basically from the last path that the machine is going to cut. It's gonna try to directly move to the 0 position, and it's basically gonna leave a big diagonal line over all the traces that you already cut. So this is important to set to something like 2 or 5, really depends. Let's set it to 5 actually to see the difference. Then in this case, we're not controlling the machine by using our computer, like a custom software, like a WebSocket software. We're going to use the actual original control software of Roland, MDX-40. So we need to replace this with the file save dialog module. So we go, so we right click, go to modules, open server module, and look up file and save. You can click on the output and then input, and it's going to be connected. So now, when we click calculate, it's going to run an algorithm which is going to calculate the paths. So you zoom out, we can also see, we're able to see how that happens all over here. It's going to offer us to save the file. We want to save it. And here's a 3D visualization of the paths that it generated. As you can see, so around here, so where there's more black space, you see there's this offset that I was talking about. So it's 1, 2, 3, 4, 5 lines, like an onion. So 5 onion layers. And you can also go like this. So, and as you see, it's just one layer. So you're just gonna go 0.1 millimeter below the origin. So this is the origin that we're gonna set, and just move the tool along these lines, so to say. And then the next, what we need to do is to open vPanel, and with the vPanel, you're able to actually control the machine. And the most important part here is this movement panel over here, and then also like the actual coordinates over here, and how fast you can move in the 3D space. So if you have high speed selected and you press and hold this arrows, then it's gonna run around the space in the fast mode. So when you switch to high speed, be careful with the Z-axis. So make sure that before you click these buttons that the tool is not about to crash into the surface, so into the material. And there are other functions. So one important thing before we begin is to set the spindle speed to the one that we want to actually use. So it's how fast the spindle is gonna turn the tool. And since we are using the SRN20 program in mods, it is not setting the spindle speed automatically. So if you would be using vcarve to generate paths for this machine, then it is capable of setting the spindle speed. But in this case, we need to set it manually. And here you should set it to 9,000. So revolutions per minute. We need to set up the material. And in order to do that, you should use double-sided tape. And the double-sided tape is quite nice. So this specific type, because it matches exactly the width of the copper-covered clad. Then you remove the backing tape, is it called like that? And position it somewhere on the surface. So try to choose a spot which is as flat as possible.
So just anywhere?
Yeah, pretty much anywhere. And I'm gonna use something like this to... no, I'm not really cleaning, I'm just pressing it against the surface so it sticks better. And at this point, you can move the tool to So the closest left corner, that's kind of the recommended setting. And here I can switch over to low speed. It's going to move slower. It's going to allow me to see more precisely where am I setting the origin. So the corners are right. And you can set the X and Y separately or together by using this setting. And when I hit apply, you'll see that this X and Y sets now becomes 0. So that's the X and Y origin. For the Z axis, we want to use the sensor. So it's a cool feature of this machine. So you, like with the other machine, you will need to set it manually, but here you can actually use this one. So there's a sensor which basically can feel when the tool is touching it. And then the software knows the thickness of this, and depending when it is touched, so the software is setting the Z origin. And it has to be, just double check whether the connections are all right. Then put it under the tool, on the material. Remember to close the lid before you start the process. And then in order to set the Z origin, hit this button over here. So the radio button, set Z origin using sensor, hit detect, hit continue. And now it's moving downwards. Yep. Okay, the operation has finished, and it's important to open up the lid and put the sensor back in place. And now, before we start milling, we override the settings so that we start with lower cutting speed. So let's set it to 40% at first. Spindle speed should be as fast as possible anyway, so I'm going to leave that 100%. So the cutting speed is going to be but the percentage of the feed rate that we set before. So as you remember, like in mods, we set the speed to 1.5 millimeters per second. And yeah, so this speed is going to be 40% of that speed that we set. So. And then if you see that the cutting is going well, then we're going to just increase it to 100% real time. It's important to check the setup. So if you're using mods, then it's going to generate as RML1 code. But if, for example, if we use other post processors, then it is possible that we can also generate NC code sometimes. So just to be sure, open up these settings to check whether everything is as you are expecting it to be. Yeah, with mods you can be sure that it's RML1, but then just later on in the course it's going to be important for you to check that you're using which post processor are you using in order to generate the paths, and then depending on that you will need to select NC code. I wouldn't go with the select automatically because I'm not really sure what is the way, so how does it detect whether that's one flavor of the code or the other. So I would recommend you to kind of learn the difference. But this is fine, so I'm hitting OK. Then the next is to hit cut. It's going to open us a dialog where we can make a list of files that we want to cut. So if we're using the same tool for multiple jobs, then you can list all the jobs here, and the machine is just going to repeat them one after another. In this case, I'm going to delete all and add the file that we just generated. So if you go to desktop and then test, I think I put it in it's in the downloads folder, so I need to cut and put it into the test folder over here. Yep, like so. Alright, so here it is, line test PNG. I'm opening it up, and then so this output button, so when you hit it, it's gonna tell the machine to run the job right away. So you hit. So it seems that it's milling well. So if it's milling well, it can increase the speed gradually to 100%. Yeah, so now we just wait a little bit. So, okay, so now it finished milling. So once you've finished, so the easiest way how to check your work is to press the view button over here. And here, the fastest way to clean it is to just use a brush. And we can open this up. And here we go. Looks quite alright. So yeah, before we take it out, we need to cut it out. And for that, I'm going to change the tool. So first I'm going to remove the 0.4. And a good way to remove this is, so always remember, you keep the big key in the left hand and then the small key in the right hand. And to make sure that you are not damaging your hands, try to make an arrangement such as this, where in order to release the tool, this was bad. You can grab the keys with one of your hands, and then you press them together like this until it nicely releases. So if you keep the keys in both of your hands and you try to go counterclockwise, then it's very likely that you're going to crash them together. So because at first it's going to be hard, then the thread is going to loosen up and it's going to crash. So just to protect your hands, take this into account. So, and try to handle the tool as careful as possible. At some point it's going to break for sure, but just to make sure that it doesn't break too soon. So put it back in the casing, and let's take the 0.8 millimeter one. Tighten it. And now, in order to proceed, we don't need to change the X and Y origin, but we need to change the Z origin, because after every tool change, since it's a manual operation, we cannot really set the tool with our hands as precise as a machine could do. So that means that we should move the tool somewhere above the material again. And again, you take the measurement tool, so the sensor, put it under the tool itself. And move it down a little bit closer so it doesn't take too much time. And before proceeding with the operation, you want to close the lid. Then you select ZZ origin using sensor and hit detect. Yeah, wait till the operation is completely finished. Hit OK, open the lid, remove the tool. So we go back to mods, and instead of this image, we load the other one. And we select the mill outline preset. And since we know that it's 0.8 tool, set it to 0.8. And here is where the cut depth is being set for one step down, so for one pass. So for the maximum depth is how much we want to, so how thick the material is, so how deep overall we want to cut. But then with the milling tools and in CNC milling, like in general, we never cut thick material in one pass unless we have a very powerful machine and there's a tool that is made for it. where we use a process that is called like adaptive clearing. And usually, like the depth, how deep you can go into the material, it's usually less than the diameter of the tool. So if the diameter of the tool is 0.8, then 0.6, it's like 75%. So that's kind of a rule of thumb that things probably gonna go all right. And we know that the copper covered clad, the thickness of it is 1.6 millimeters. So in order to make sure that the tool actually goes through, and we can afterwards remove our board from the material, so we're gonna just cut a little bit deeper, so 0.2 millimeters deeper. So we're gonna overshoot, and it's gonna cut a little bit into the sacrificial layer or the spoil board. And for the offset number, we're gonna specify 1 because we just want to go around the outline of the board once. Then we want to set up the speed to something a bit higher, like 2 millimeters per second. It's going to show you the values. So for the recommended values for these tools at the other machine. So everything else here we can leave the same pretty much, and then we can hit calculate. Save the file. I'm gonna cut and paste it here. So, and you can also check the visual. So here you don't get the 3D visualization. Ah, no, here it is. Just open another tab. So as you see, there are 3 blue lines basically, and each of the lines is for 1 layer of cutting. And what is this long blue line over here? That's a question. It's interesting. Let's see, it's probably gonna do something weird, but okay, we're ready for that. So yeah, so what's gonna happen? The tool is gonna. So this is the origin again. You see from a side. So the first line is already kind of offset, like below the origin line. So this point specifies basically where the tool is at the top of the surface, and then imagine it going into the material and then downwards and then following this path. It's going to do it once, then twice, and the third time, so until the whole thickness of the material is going to be cut. Okay, and now let's go back to our control panel. So again, double check that we have 9,000 revolutions per minute set up here, and we can hit cut. Remove all of these, add, and
here we start at full cutting speed, or
sorry?
We start at full cutting speed?
You mean the 9,000?
No, I mean the 100%.
Yeah. So actually, yeah, that's a good note. So you should actually reduce it to, say, 50 at first, and then we want to select the interior job. So the job that we just created, the RML file. Hit open. Hit output, and the machine is going to start cutting. Finished board, you hit view. You wait until this comes forward fully. No, it's fine. So in this case, you can just use the brush quickly, so I'm going to clean up later. And you can use one of these stronger knives. So there's a round knife in order to remove it. And that's what you got. So wait, I will first show it into the camera. So it's sharp enough.